All right, here it is, graphing calculator day. So hopefully you've picked up a calculator and something that you can use, at home, whatever. Like I said, there's emulators you can install on your phones that you could use to get the hang of using a calculator and do your homework at home, but not for tests in my class or the AP test. I'm going to be using, this is just what I have some extras of, TI-83 Plus, which is very similar to a TI-83 and TI-84, and very similar to a bunch of TI editions. Once you get to some of the higher numbers, they get fancier. I'm sure the menus are similar, but might be a little different. If you have a different brand, the way you do things will probably be quite a bit different, which buttons you press. But if you have manual, or you can just search, you can probably figure it out pretty quickly. We're not going to actually, these calculators have tons of potential, but really there's only a handful of things that you really need for the AP test. So just some quick things, at least on this one. Let's see. Let's see. Memory. So on this calculator, that is under the plus symbol, second plus. So you'll notice that all these buttons have a little upper right hand corner, upper left corner function that you access with the second. And then alpha is for alphabet. So those are actually letters that you can really just store values in, like variables, but I don't know. They could be helpful. But the memory, second plus, all right, let's see. Second plus brings you to memory. And on this calculator, you clear entries, clear all lists. So you can kind of like clear a bunch of information that's out of it. The memory management says RAM free, ARC free. Those are the different kinds of memory that's available. You probably want your RAM to be under, you want it to be over 2,000. So mine's 23,000. So that's pretty good. Anyways, let's see. There's another way to kind of see where your battery power's at, because it really stinks for the battery to go dead in the middle of a test or something. But as the battery dies, the screen will get dimmer, and there is a way for you to darken the screen so that you can still see it. But the more you have to do that, then clearly the more the batteries are dying. So if you do second up or down, that will, like, they actually show this right here. There's these different symbols. It's funny, I never really thought about that, but this one's like daylight, sun, dark. So if you go second up, you'll see a number flash in the up right hand corner. The darkest number, I think the darkest is like 9. So, it gets to the point where the whole screen's dark and you can't see anything. So that's dumb. But as you lighten it up to an appropriate level, that's kind of like, your battery level. So the higher that number has to be, 9 is the worst. That means your battery's getting close to dead. So you should probably replace them or have some fresh batteries. So let's see. There could be some different issues that pop up. I've been pretty familiar with, like, especially if you're using this for like other classes like physics. You're going to be degree mode a lot. In our class, you're primarily going to be Radian Mode. In stats, if you turn on some stat plots and things like that, that could mess up you trying to graph things in calculus. So if you when we go to graph things, it's up here, this top row, and you see stat plot. So second stat plot. If you have anything, second stat plot, you want these all turned off when you're doing your calculus stuff. So, because if you have one turned on and then those lists end up being empty, it'll give you errors. And if this causes an error, then you won't be allowed to graph anything. But we'll talk about these stat plots later. We're not going to really use them, but I'll tie them to something that we're going to do. So let's get to the notes. So on these notes, I've tried to offer a lot of extra notes already on there. So you don't have to write as much stuff down, but I would probably be still writing stuff down. And, you know, at least at first, I'd be writing down the buttons you push, the sequences, the order of where you find things. Not that I need that on homework, but you might be writing that on homework, you know, until you start to remember where they're at, you know. I think it's just good to have that as a reference. So for these first two problems on your graphing calculator, see if you can go and just calculate these simple algebraic expressions, because there are some subtle things you got to watch out for. So also, by the way, we want answers on all AP questions on the AP test, free response, multiple choice. They're going to be 3 decimal accurate, and it can be rounded or truncated. Okay, so for instance, as an example, if your calculator gives you 2.5647, you know, then 2.565 is the rounded answer. You would round up this time. You look at the fourth digit. Truncated means, truncate is kind of fancy word, just cut something off. You just cut it off no matter what. So I personally like truncating because it's hard to mess up. Rounding, you can mess up. Sometimes you round up, sometimes you round down. So sometimes the rounded down answers and the truncated answers will look the same, but either one is acceptable. But sometimes on the AP test, they might say the nearest whole number. Well, then that means to round and not 3 decimals anymore. But in general, they don't say anything. It's 3 decimal accurate, rounded, or truncated. So either one, I'll probably put both on my answers whenever they're different. Just, you don't need to. You don't need to do them both. Just do one or the other. But I'll have both of them on my solution so that people who did it one way can check their answer against other people. Because if you round, people will round wrong sometimes. If you give me less than 3 decimals, you'll get it wrong. Okay? Unless it says otherwise. So go and pause the video and try these two, and then unpause it, and I'm going to show you how I did it. Okay, so the first one, I'm just going to go ahead and the thing you got to watch out for, one of the things is parentheses, because you have to enforce order of operations because your calculator is just going to do things left to right. Okay, so if you don't, now it doesn't necessarily hurt to put extra parentheses if you're not sure. So, you know, even if there weren't parentheses around the 20 over 25, I think it would work with just 20 over 25 because it does left to right. So it's going to do 20 over 25 and then calculate it times. Now the next one, and you don't even need the times symbol. If you just put a parenthesis between something, it will assume times, kind of like the way we write it. We definitely need parentheses around the numerator. Okay, so I'll show you the wrong way of doing it real quick. So if I didn't put parentheses around the numerator, which it doesn't show any there, now when you do square root, it's on the squared button right here. That's one way, or you could raise it to 1/2 power. So second x squared gives you square root. So a lot of the buttons, the second button is the inverse function. Square roots are inverses of x squared. Logs are inverses of power, 10 to the power. Now, it's open. A lot of these functions, when you select them, it opens up some parentheses. So you got to make sure and close those parentheses. Otherwise, everything after this is going to be inside that square root. Okay? Divided by 5 minus 3 square root 2. So I'm just kind of typing it the way it was originally written. Now, if you want to put something in there, if you forgot something, if you just start typing, it's going to start just copying over what you've typed. And so if you want to insert something, which is kind of the normal way text, documents work, text editors, if you just put your cursor somewhere and you start typing, it pushes everything over. That's called inserting. So you have to get to the place where you want to do it and do second delete, insert. Then whatever you type, it will move everything over. Now, as soon as you stop typing, it goes away. So then if you want to put one here, you can do second insert. So that's quicker than retyping it all. Now, if I hit enter, it gives me this answer. And I think there's some things wrong with this. So I got 2.310 or 2.311, but that's wrong. Because what it's doing is it's doing this, and then I think the top we don't have to put parentheses around it because it should be doing left to right. We definitely need parentheses around the bottom. Now, if you typed all this and you don't want to retype it, there's another trick. My calculator do second enter, which is entry, and what it does is it copies and pastes to the last command line, and then you can go in and make changes to it. So it's a lot faster and sometimes you're doing the same calculations over and over again and just making tiny changes. That's really helpful. It saves a lot of time. So not only do you need to know how to use these calculators, you need to be fast and quick at them and kind of figure out tricks to save time, because time is going to be an issue on my test and AP test. So I'm going to put in, I'm put parentheses around the denominator. I think that might be the problem. So, and I don't know if, okay, let's see. Let's try that. So that's the answer. And that one's actually still wrong. Now that one, rounded truncated, is the same. Now I think we need to go and put parentheses around the numerator because it seems like it actually is maybe doing the division before the addition. I'm not sure. Let's see. So now if we put parentheses around the numerator and they weren't necessary, it shouldn't change the answer. So, I mean, if you're not sure, you could always put extra parentheses. Now, that gives us a different answer. So, it was messing up. So, the answer is 12.313. Rounded or truncated, it's the same on this one. We could probably go in and get rid of some of the parentheses. Like, I don't think we necessarily need the parentheses around the whole second fraction. Same answer. We don't need parentheses around the first fraction, I don't think, because it's going to be done left to right. Same answer. But I think it does actually do some kinds of order of operations on here. It seemed to maybe do the division here before the addition when we didn't have these parentheses. So that seemed to make a difference. So anyways, like I said, you can put extra parentheses and it's not going to make a big difference. So here, try this one. Now, let's see. So, I mean, I think we need parentheses around everything on top. Now, signs right here, 47.6 plus E. Now, there's a couple different ways to do E. Here's E to the X, which then gives you E with an exponent ready to go, or just E right here. So you could do E squared, close it, or you could come over here and do second E, and that just gives you a number E, and then you could put the X squared button. That's the same thing. Or you could do E and then put the caret symbol in yourself and put the 2. So there's a bunch of different ways you could do that. Divided by, we need parentheses around the bottom, 10 to the, so negative 0.2. Now you got to be careful when you raise things. That's called the caret symbol, by the way, that little pointy thing that we use for powers. That's caret symbol. So we can use that to raise things to powers. If the powers have anything more than just a number, like they have multiple numbers or, algebraic expression or variables, then you need to put it in parentheses. Otherwise, they'll just raise the very first thing. Now, the negative, I think it will deal with correctly. But often, we're going to be putting parentheses around our exponents if they involve more than just a number. But I'll take them off afterwards and see if they give the same thing. Plus square root. Now pi is right over here on the caret symbol. Second caret symbol gives you the pi symbol, plus 1. Don't type in 3.14. We want it to be 3 decimal accurate when we're done, which means we need more than 3 decimal accuracy in the middle of our work. Close parentheses on the square root. Close parentheses on the denominator. And this is what I get. 3.048 or 3.049, which is the right answer, rounded or truncated. Now, let me make a quick change. Second enter. Let's get rid of the parentheses around the exponent. I think this one would work because it's just a negative number. So, yeah, same thing. Now, things you got to watch out for is your calculator might be, if you go to mode, might be in Radian mode. So you can select what kind of units for angles you're using. And if you do that, which we're actually going to usually be in Radian mode, you do second mode quit to get out of that. If we do the same thing with all the same exact stuff, it gives us a totally different answer. 2.599 or 2.600. This would be if we were in Radian mode. And if there are no units on the angle, then you should assume radians actually. Okay. Degrees usually have the actual symbol there. You could do a little superscript R for radians. Now, there are ways around this. Let's say we're in Radian mode right now, which we are. You could force it to do degrees by inserting the degree unit right here. So second insert, and then if you go to the angle menu, which is right above apps, second apps, you can insert degrees or even minutes, which are 60th of a degree, or little r, superscript R for radians. But if I put that degree symbol in there, even though I'm in Radian mode, it will actually give me the degree answer because I forced it to be degrees. It'll recognize that. But usually you just kind of flip back and forth between degree mode and Radian mode because it's usually one or the other. And after this unit, or after next couple units, we'll probably never do degrees again. There are no degrees on the AP test for calculus. Now in physics, you're always doing degrees, so go watch out if you're going from physics to my class that you remember to change your calculator. I've had students do a whole test in radians accidentally, or in degrees accidentally, and realize it at the end before they turn in and redid all their answers in radians. Okay. So anyways, there's some little things over here. This copies and pastes your previous command line. This inserts, if you want to put something in and move everything over as you're typing it. Second division is how you get the E, just E by itself. Second natural log gives you e to the x. Second caret gives you pi. So just some little things there. Radian mode, enter second mode quit. So this was just showing you how to get on this calculator to how to change it from different modes. And then to get out of it, you have to say second mode quit to get out of it. Going to be radians most of the year, leaving radians where it says there is a way around for degrees without changing mode. Second apps angle 1 is the little degree symbol. So I showed you guys that. Okay, now using a table on your graphing calculator. So this will be handy a lot of times. So first of all, now even if you clear your whole screen, you might be like, oh no, if you do second enter, it'll give you last command line. And if you do second enter again, it'll give you the one before that. And second enter again gives you the one before that. And eventually we can get to the first problem. So if you keep going up, it keeps those in memory. It's like a history of your commands, and you keep hitting second enter and it goes through those. We're going to go to the Y menu. If there's anything there, you should clear it. Let's type this equation in right now. So for tables and for graphs, we enter them into the Y menu. And it's like a formula you're going to use for multiple calculations or whatever. So we've got to put parentheses around top, x squared plus sine x. Now, because when you do sine, it opens parentheses, you've got to close them for the top, divided by, now the bottom doesn't need parentheses because it's all inside one big square root, which has its own grouping symbols, right? It already has that. So anyways, if you don't see any reference to degrees, or they don't say anything about degrees, then you should be in Radian mode. So make sure you're in Radian mode, and it'll darken the one that is the one that's selected. So if you hit enter on the other one, it'll change it. Okay, so make sure you're in Radian mode and enter that in your Y menu. And the way to put the X's in there is this button right here that has the X, T, theta, and N. We're probably only going to be using for X and Calc BC. We might well, the T is for two-dimensional motion, parametrics, which we're not going to do in AB, and the theta is for polar mode, which is another style of coordinate system that we cover in Calc BC. So we're always going to be on X, and it'll automatically give you an X, like depending on what mode you're in. If it's giving you the T or the theta, you should go to mode, and it's down here. Function is what you guys should always be in. PAR is for parametrics, two-dimensional motion. POL is for polar. Sequential is this weird way of graphing multiple graphs at the same time, like actually graphing them at the same time, not graphing them on the same graph. Okay, so the way if we want to do a bunch of calculations with this function and we don't want to retype them every time on the home screen, then this is the quick way to do it. And like I said, just because you can do it one way doesn't mean that's the best way. You want to find the quickest way. So we're going to go to table, which is above the graph button. So after you have to have your Y menu in there. Now it might already have some stuff in here, so you could delete those. It's going to have whatever was in there before. And we could just type these numbers in to the X's. Okay. Now some of you guys might have some weird stuff going on, because if you got to go to table setup, so second window, table setup, there's some stuff on here that it'll use if you change things the right way. So if we put this on independent auto and dependent auto, so independent is the X variable, dependent is the Y variable, right? And then if you do this, it's going to start at -9 and go by 2 every time. Automatically, it's going to fill the table out. Let's check it out. All right, it starts at -9 and it just keeps going and it just fills the table out. I don't think we're usually going to use that. We want it usually to ask us for the X variable and then automatically calculate the Y variable for us. So we want independent on ask and dependent on auto. And then the whole delta table and table start won't even matter because they won't get used in this situation. So now the thing is, if I go back to table, it's going to have, well, I thought, yeah. So anyways, if you have a bunch of numbers in there that are all filling it up and you can't change them, then go to the settings. So there you go. Now I'm going to go ahead and just draw a picture of this for your own notes. That's a button to get the X variable. So, we could draw a picture here. Now, by the way, if you have more than one equation, then it'll pop up and show here. Okay. And then this is where you type in, right? So you want independent to be on ask, which is the X value, and then the Y value, the output, you want it to be on auto. And then this doesn't even matter. Okay, unless you're using the auto for independent also. So this is table setup. Okay. So what my calculator shows me is 3.0485, 3.1918, and 15.788. And this is just what it displays. It will only display 5 digits, 5 numbers. Okay. So there is more accuracy available, which you might want, because if you want 3 decimal accuracy and you have a number in the hundreds, you're not going to get it. Also, what is this calculator doing? Is it just truncating the values or is it rounding them? So here's the way to see the more accurate version of any of these numbers is to move the cursor over the top of them. And then down here at the bottom, it shows you 6, 9, 10, like 12 numbers. Okay. And you'll notice that it rounds the last digit. So it rounded this 4 up to a 5. So it's rounding. And if you need 3 decimal accuracy in the end of a problem and you need to use these in future calculations and you need more than 3 decimals, you need 5 or 6 would be good to make sure your final answer gets rounded or truncated correctly. Because if you round or truncate to 3 decimals in the middle of your work, you're going to potentially throw off the accuracy of your final answer. So if you highlight it, you can you can see more accuracy. So the first one's going to be 3.408. Now, here's where you might make a mistake. If you're into rounding, which I've already said I feel like is more dangerous, you would say that this is 3.409. The problem is it's not, because if you look at the more accurate number down here, you wouldn't actually round the 8 to a 9. You would round down to an 8. But because they rounded, then it's going to cause you to round, and it's going to give the wrong answer. So be careful. And again, I'm a fan of truncating. It's hard to screw up. The next one would be 3.191 if you truncated, or 3.192 if you rounded. And the last one would be 15.787 if you truncate, even though it seems like it'd be 8. But if you go down to it, it's actually the third digit is a 7. The third decimal is a 7. It gets rounded up by the calculator to 8, which is an okay answer for us. So these are helpful for doing lots of calculation. Now make sure, this is just a little side note, that there's 2 buttons that seem to indicate subtraction or negative. There's this one, that's actually subtraction, which kind of makes sense because it's in here with all these other basic arithmetic operations. And then there's this button, that's a negative symbol. And you can't just interchange negatives for subtraction. If you put a negative symbol in the middle where subtraction is, it might treat it as multiplication. If you put a subtraction at the beginning of an expression trying to make something negative, it will give you an error. So you got to be careful. It makes a difference. Okay, now how do we make graphs? I mean, we think graphing calculators are for graphing things, and we'll use them a fair amount for that, but we're going to use them for lots of other stuff where we don't graph at all. But they are kind of cool because they can graph things. Now to graph something, you go to the Y menu and you enter the function in. So let's do that first. Go ahead and try and enter it in correctly. I'm going to enter it in. Now we don't have to have parentheses around the top because it'll do that multiplication first. But if you put them, it's not going to hurt. And then square root x squared plus x plus 1. Now you could do x squared by doing the squared button right here, or you could do caret symbol 2. If it's squared, I just do that because it's quick. If it's another power like cubed or something like that, I don't want to go find it in some menu. I'll just do caret 3. Okay, so that's entered in correctly. Put that. Now I'm putting this into Y1, which is something, you know, we're gonna have multiple graphs sometimes, and so you want to keep them straight. Now we want to sketch it in this window. So how do we make the, if you just hit graph right now, it's going to be some weird window. Like, I don't know, mine's not that weird, but it's not -5 to 5, -3 to 3. So usually before you ever hit graph, because what it's going to graph it and whatever the last window was that you used on some other problem, that's probably totally different than this problem. So we always want to go to window first and decide ahead of time what we think the window should be, or just make a guess if we have no idea. But we want to do that ahead of time. Otherwise, you're just wasting time. Now, in the window here, I can set x min to -5, x max to 5, y min to -3, and y max to 5. So you can tell it the extreme x and y values to show, and then you should probably just keep the scale and resolution to 1, and then graph it. So now it's going to give you a nice graph that fits in this window. So let's see if we can sketch it. It doesn't need to be perfect, but it does look like there's a little dip right there, and it kind of looks like it goes through the origin. And it does keep going. So I don't know. It's just by the way, so here's the window stuff. And then you hit graph. Okay. So after you enter your equation, you want to go to the window before you hit graph. Now, let's answer some questions about this. Find F2. Now, F2 is the value of the function at 2. So you could just type all this in on the home screen and put 2's where the x's are. You could go to table, and now you'll notice it has the x values we used for the last problem. So you could delete those. and put a 2. Okay, so you could do it that way, 1.511 or 1.512. You could do it from the graph screen actually. So if you go to graph, you could go second. Now a bunch of stuff we're going to use is up here on the calc button, second trace calc, and you could say value, option number 1. And then it shows you the graph and it asks you for x, and you type it in, x equals 2, and it'll show you the y value in the bottom left corner and a little blinking thing. So you get it that way. Now the minimum value, is the absolute minimum, the lowest point on the graph that we can see, which I think is like right around here. This looks like the absolute minimum. Now, if they say minimum, that means absolute, which means the lowest point. Relative could be just a low point on one portion of the graph. Now, your calculator can calculate this for you. You don't want to guess. So under the calculate menu, there's an option number 3, minimum. There's an option number 4, maximum. And I'll do that for you. So you got to tell it where to look for it, because it's going to find the one. You're going to help it. It'll find it quicker if you give it directions and kind of zone in on it. It looks like it's around -2. So I'm going to say, between -4, left bound is how far to the left should we start looking for it? And maybe 0. So hit enter and then 0 for the right bound. So you got to tell it where to look, and it shows these little arrows. And if it's not between these little arrows, it's not going to find it. If you give a right bound that's to the left of the left bound, I'll give you an error. So then a guess. And so you could use this little cursor to get close to it, which sometimes is kind of annoying, or you could just type the number that you think it's close to, like -2. And then it's thinking right here, and it finds it actually was exactly -2. So I'm going to write those coordinates on my picture. So a lot of times when you're finding stuff on a graph for a more complicated problem, I think it's helpful to just write it on your picture, just to help you keep track of it, not lose it. So now the way we write this answer, you got to be careful here. The minimum value is the y value, okay? And that's going to be this is actually a common calculus question. The minimum value is -2.309. That is it. That is the answer. If you write the coordinates -2.00, -2.309, that's my answer. Nope, not good enough. Okay. So what we want to do is we want to say, and by the way, this is the directions for how you found it. You could have multiple mins, like relative mins. So it's not really, so left bound, I think we typed in -4, right bound, we typed in 0. You could use the cursor or type in, or you could use your cursor to find the bounds, or you could just type it in, right? Anyways, this is the way I think you guys should answer these questions, and I'm actually going to require it on your first test. And if you don't do it like this, I'm going to take off points, because this is going to be the root of a lot of mistakes and points taken off on the AP test if you don't get in the habit now. I'm going to make you guys do this every chapter. So the best way to write this answer is the minimum value is -2.309 at x equals -2.0. Sometimes they'll say, where is the minimum value? And this will answer where or what it is, or where it is and what it is. They'll ask you sometimes for this, sometimes for this, sometimes for both. If you answer it this way, you're always safe. If you answer like this, you're not. That's always wrong. Now, there's different ways to zoom in. So you could go zoom, and zoom standard is a lot of times what I use if I'm not sure. And these numbers over here are shortcuts. So if you just type the number, you don't have to go up and down. If you do zoom 6, it zooms it in -10 to 10. Standard window is -10 to 10. Zoom box, I like to use if I'm trying to get to a certain, and zoom box is number 1. And so if you can create a little box, one corner, and then hit enter on the other one, and then it'll zoom in on that portion of the graph, which is handy sometimes just to zoom in on a very specific portion. So I use those a lot. But this second trace calculate, we're going to use all the time to help us calculate things from graphs. Okay. So in the back, we're going to figure out how to do some other algebra problems. Actually, some problems that we've been kind of doing lately. I want you to make sketches of your graphs for your homework. Otherwise, I'm not going to give you credit. Same thing on tests. Because sometimes you're going to graph something wrong, and you're going to do everything else right. And your answer makes sense. So I want to see a sketch graph. Plus, I think it's helpful just for, showing your work and keeping track of stuff. So graph these two functions in a standard window. That's -10 to 10, by the way. And find the points of intersection of y1 and y2. So we're going to go to y here. We're going to type these in. X squared minus 6x. Delete, 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 delete. Or you hit clear. And then x plus 2. And then we're going to, you could either go to window and type in -10 to 10, or you could go to zoom 6 and I'll do -10 to 10 and then graph it. So the first one's a parabola, right? I mean, this is a good thing. You should know what these graphs are going to look like. So if you type something wrong and it looks really weird, that you'll know it right away. So let's draw a sketch of this. The parabola looks like it's going through the origin, just rough graph. Nothing perfect. And then we have this line over here. And the second graph should be a line. So this is y1, which is x squared minus 6x. A lot of times I like to label these to make sure I keep track of which one's which. I mean, clearly this is a parabola and that's a line, but sometimes you might have two parabolas. So the intersections are right here and here. And that's an algebra problem. If you were going to solve this by hand, you'd set these equal to each other and then solve it. Solve the quadratic. So the way you do it here is you second calculate and number 5 intersect. Now, if you just hit the number, it'll select it for you. Now, you got to tell it which curves. It says first curve. Does it matter which one's the first? No. Second curve. Does it matter which one's second? No. But if you have more than two curves, it can only find intersections between two curves at a time. So that's why I asked you. But if you only have two curves, hit enter. Then ask for a guess. Now, the cursor will just show up somewhere on your screen. You can move it closer to the one you want to find. Now, it's going to find the one it's closest to when you guess. Or you could type in like, I'm going to guess x equals 0. And the closer it is, the quicker it finds it. So I'm going to write this on here. -2, -0.2749172, comma 1.7250828. Now I'm writing all these extra decimals because if I need this for a future calculation, I need more than 3 decimals. And if I find out later that I needed it, it's going to be a lot more work to redo these and then write it down. Second calculate, number 5, intersect, first curve, second curve. This one looks like it's around 1, 2, 3, 4, 5, 6, 7. That's quicker than moving the cursor over. 7.2749172, comma 9.2749172. So the answer is, for the first one, for this one, it's -0.274, comma 1.725. Now, I only want 3 decimals for answers. Now, you could have, that was the truncated version. The rounded version would have given you that there. So that's one answer, or that, but the y would be the same. And the second one is 7.274, comma 9.274. Or if you rounded, it'd be 7.275, comma 9.275. So that's okay. I just want 3 decimals, rounded or truncated for final answers, but keep extra decimals in your work. Now, the next question, solve x squared minus 6x is less than or equal to x plus 2. This looks like the problems we've been doing like all since first day of this class, right? So how do we do that on a graphing calculator? Well, one way is to say, okay, well, enter this as a formula, which coincidentally is the same. Enter this as a formula, and it's asking you where is the parabola below the line or equal to it, right? Well, we can show that this is where the parabola is below or equal to that line. In fact, we can use our work right here to write the answer. The answer, interval notation, is from x equals negative 2.274 to this x value. Because we're solving for x's. It's all x's here. So you could do that, and then you put brackets on it because it was or equals to, right? Or you could round it 3 decimal accuracy. Okay? So definitely need brackets, right? Because it's or equals to. So that's an interesting way to do it. Now, here's the deal. Usually I'm not going to probably do that unless I have the graphs already graphed. A lot of times you're going to solve things like that without being asked to graph them first. So this graphing thing we might do. Now, look at this one. Now, before you graph things, even on a graphing calculator, you might start to sketch them. Like, now, this is asking where is this graph above or equal to this graph. So we can go in here. Let's enter these in real quick. X divided by parentheses x plus 3. And this one's going to be 2 divided by parentheses. You definitely need parentheses on these denominators. And I don't know what window to graph it in, so I'm just going to do zoom 6. Now, that's the first graph. Now, this is what my calculator does for vertical asymptotes. Now, this isn't that bad, but this is hard to look at. Can you tell me which one's above or below? Which one is which? I mean, this is really confusing. And those vertical asymptotes are making it hard. Like, this is going to be hard to use to do the way we did before. So what I'm going to say, instead of saying where is this above this, I'm going to do it a little differently. Okay. It's a crazy graph. Okay. If you do it like that. So what would be better is to do what we do. What do we do when we solve these by hand? We move everything to one side. So in general, if you're going to solve an equation or inequality on your graphing calculator, move it all to one side equal to 0. Now, all the other stuff we did, we don't need to do that. We don't need to make it into a single, because we're not doing a line check. That's going to be better. Okay. Now, we did go through the process of typing these in. We could take advantage of it. We could actually, this is something I'm going to use a lot. We can refer to certain y equations. And so the way you do it is you go to vars on my calculators, which stands for variables. And then you go to y variables, which is talking, these are considered, this is y1, y2. And you could go function, and you could say, I want to do y1, and it puts a y1 there, and it's going to treat it as if it's that minus vars, y vars, function y2, and it'll put what's in there. Now, I don't want these other graphs in the way, so I'm going to turn them off. So the way you turn equations on and off is you go to the equal sign and you hit enter. And if it's not dark, it's not active. This one will still do them, but these just won't get graphed, or they won't show up in your tables either. So if you have a lot of equations from various problems that you don't want to delete yet, that's kind of a trick to having them there, not deleting them, but having them not become a distraction. Or we could just type it in, okay? So we're going to graph this. You could either type it in like this, and then we're saying where is it greater than or equal to 0? Or you could do y1 minus y2, vars, y vars, enter, like that's the way you could do that. And then you could turn off y1 and y2. So a lot of those notes are already there. So I'm going to graph this one. Now, before I graph it, I think we should do a rough sketch, because now all we're doing is we're going to do one graph, and now we're asking where is y3 above the x-axis, right? Or equal to it, which is a lot easier to look at one graph and to only have to compare it to the x-axis. That's way easier too. Finding intersecting graphs is really complicated. Now, before we do that, let's do a rough sketch because there's some obvious things on here that you should know. Like there's a vertical asymptote right here at x equals -3, and there's another vertical asymptote at x equals -2. So you can tell vertical asymptotes before even trying to combine them into a single fraction, okay? And as x gets really big, these denominators get really big and the whole answers get really small. But yeah, so it's going to do some different things. Actually, it's going to probably go to like 1. I don't know if you guys studied in pre-calc, you guys probably did horizontal asymptotes. So you could get away without this. But these are the vertical asymptotes. The vertical lines are x equals number, horizontal lines are y equals number. It's just good to have a basic idea of what's going to happen so you make sense of the graph. So now I'm going to graph it. I think the window could be -5 to 5, or even, like, I mean, just looking at, that's where things, I don't know. We'll leave it -10 to 10, -10 to 10. Now, a lot of times be comfortable with going back and changing the window after you graph it so you get a better view of it. So, boom, that's vertical asymptote. That's a vertical asymptote. That's actually not part of the graph. A lot of people might think, oh, there's an X-intercept there. Nope. That's what my calculator does. Some of the better versions don't do that, and that's fine. But that's what my calculator does. So it looks like it's like going like this, right? And then it's going like, so vertical asymptotes is going to go towards them on each side. And it looks like it has an X-intercept around here somewhere. So I just kind of roughly put that there. Now, where is this graph above or equal to the x-axis? Well, I think all of this chunk, right, which appears to go to the left forever, and then this chunk is above or equal to. I'm put a solid dot here on purpose, and then this chunk solid dot because of the or equals to. So this is kind of like a line check, but a 2D version. Those are our answers. So, I mean, I could write probably most of the answer right now because I understand what this graph is doing. It's going to be -infinity to -3, but not including -3 because of the vertical asymptote there. Union, bracket, some value, whatever that x coordinate is, comma, -2, because that's the next vertical asymptote. Union, bracket, whatever this number is, to positive infinity forever. So, I mean, this is your answer. The only thing left to do is to figure out what those two x-intercepts are. So the way you find x-intercepts on a graph, second, calculate 0, which is another name for a root or x-intercept. So 0, and you got to tell it where to look for it because there's multiple ones. So you're like, well, this one's between -3 and -2. So I'm going to say left bound is -3, right bound is -2. This is just like finding the intersections of graphs. You got to tell it where to look for it, and it shows the arrows. And then guess. I don't know, -2.5. Now, if you guess outside your left and right bounds, it'll give you an error. And so the answer is -2.44949, 0. Okay, I'm going to write that on my graph just in case I need it for something else, just to keep it straight, just to help my teacher give me partial credit on my test or I mess something up. Second, calculate 0. The other one looks like it's around, I don't know, 4 or something. I'm going to say 2 to 8, guess 4. And that one is 2.44948997, 0. Now, did I just find the same one? Maybe. I think this one's supposed to be negative. Let's try it again. Second, calculate 0, -3 to -2, guess -2.5. Yeah, it's a negative. And it's kind of weird. They're both the same x values almost, it looks like. As far as I can tell, I don't know, it's kind of interesting. So the answer is, this is going to be a -2.449. Round and truncated comes out the same. This one's going to be a positive 2.449. Round or truncated comes out the same. So this is the answer. So that's a way to do the problems we've been doing in class under calculator. Now we can even do absolute value inequalities. Okay. Now, the way you enter this into your calculator is on my calculator, there's an absolute value function, which makes things a lot easier because then your calculator does it all for you. So go to Y. I'm going to get rid of these. And we could do, it's under the math menu on my calculator. Math, num, first option, number 1, ABS. Okay. And then it's going to be x to the third. Now, I just say x to the third. I'm sure there's a cube function in some list somewhere, but I feel like that's going to take more time. x to the third plus 2x minus 3, close parentheses. And then we could graph this other one separately. This one's simple enough that you could probably just graph these two and say, where's the absolute value function below the horizontal line, y equals 5? Now the window, I don't know what it should be. We could do zoom 6 standard, -10 to 10 if we don't know. And then sometimes we might want to zoom in. There's the absolute value function, which isn't a perfect V because it's not a linear absolute value function. And so let's draw a quick sketch of this because that's what I want on your homework, to give you credit on today's assignment. And it kind of goes like that. And I'm going to say, okay, that's y equals 5. This is y equals absolute value of x cubed plus 2x minus 3. And I'm saying, where is it below it? So it's below it here. Open dots, because it doesn't have the or equals to. Okay? And so then the way I find that is I do second calculate intersect number 5. First curve, second curve. I'm going to guess the first one looks like it's around -1. And it is negative 0.770917, comma 5. And then the next one, second calculate option number 5. First curve, second curve. The next one looks like it's around 2. So it's quicker to just type the number for your guess than to like put the cursor back and forth. 1.670247, comma 5. So your answer is, this is the x values, it's parentheses negative 0.770, comma 1.670. That's your answer. You could round the first one and be negative 0.771, but the second one would be the same round or truncated. The other way to do it, because like I said, I think usually what I'm going to do is I'm going to just make it a single graph. So we could subtract the 5 over to the right-hand side and compare it to 0. That's what we do when we do these by hand usually. Well, not absolutely by hand. So I'm going to do that, turn this one off, delete it. It'll automatically turn it off if you delete it. If you start typing something, it automatically turns it on. So usually you don't have to worry about it. So if I go to the graph, if I graph this, it's going to be a single graph, and I want to know where is it below the x-axis, which is easy. It's a lot easier. And then we just find the zeros. Now they're going to come out the same. Second calculate 0, and it tells you where -2 to 0, -1 is my guess, and it gives you negative 0.770917, comma 0. Second calculate 0. Looks like it's between 1 and 3. Guess at 2. So you can get really quick at this. 1.670247, comma 0. And then you would get the same answer that we got. Now, some of these numbers are actually, they might be slightly different sometimes because of the techniques you're using. But 3 decimal actually should be good enough. Okay, a little calculus. Find the slope to this curve. Now, the way we find slope on a calculator is by doing derivatives. Okay, so this is all about derivatives. And so I'm going to have you maybe do some with your calculator. You don't have to do them by hand. Now, by hand, just to show you, we use this prime symbol for derivatives, by the way. And so the derivative of this function is 3 times e to the x. It's actually the same function. So then if you want the derivative at 2, you plug 2 in. Now, if you've never seen this before, don't worry about it. I'm going to be going through the basics of it in much more detail later on. So we could just type it in on our calculator. 3, if we know how to do it by hand, which you guys necessarily don't yet, 22.1671683. So the derivative, which is the slope of a tangent line. So if you have a curve and then you have a tangent line, the slope of this tangent line is the derivative, which is also the slope of the curve, the rise of run at that particular point. So the slope here equals 22.167. Now, another way to do it is let your calculator do it. So you could do it from the graph screen. You could enter this equation in, 3 to e to the x, and then you could graph it, -10 to 10 window. So there's that graph, which is the exponential graph. That makes sense, right? And then you can do second calculate, and it has dy dx. That means that's derivative. That's another way of writing the derivative instead of the prime notation. And so you hit that, and you got to enter where you want. Type it in. X equals 2. Hit enter, and it gives you the answer right here. Same answer. Or, so that's a way you could do it using your calculator, which you're going to want to do in your next test. And then the other way, and then you could do that for 5 also. Or from the home screen, you could do, we do a lot of these calculations in the math menu at the bottom of it. Now, the quick way to get to the bottom of the menu is to go up from the top. Okay. And number 8 is in derive. So you could do math option number 8 in derive. And then if you enter on it, it brings that to your screen. Now, some of you guys have better versions of mine, and it actually shows like a dy dx notation more. So here you got to put your function. So this is where you put 3e to the x, comma, and then what are you taking the derivative with respect to, which is always going to be x for us, and then comma, the value you want it at. So if you want it at 5, this will do it for you. So if we do this, we could do 3e to the x, comma x, comma 5. And that gives you the slope. So we could say the slope here equals 445.239. If you round it, it's 445.240. I'd write the 0 because that communicates to me that you're rounding to the nearest 3 decimals and not 2, even though it happens to be the same. So you could do that. So, I mean, that's the same answer we would get from the graph screen. And by the way, another trick is you could say math 8 and derive, and you could do vars, y-vars function, y1, because we typed that in already. And now you don't have to retype it. Comma x, comma 5. Same answer. So if you type something in Y menu, even if you don't plan to graph it, it's helpful so you can copy and paste it for multiple calculations. Another way you can do it from the graph menu is you could go to the draw menu, and mine is above program. Second program, draw, and number 5 is tangent line. And what it does is, if you say x equals 2, it'll draw the tangent line at x equals 2 and give you the equation of the tangent line, which has the slope because lines are right, y equals mx plus b. So if you go second program, so this is kind of a tricky, quick way to get the equation of the tangent line. And then you do x equals 2, and you hit enter. So I'm just trying to draw the notes here. You get at the bottom of the screen, it shows you the slope-intercept form of the equation with a lot of accuracy. Well, but then it kind of cuts it off. But this is your slope right here. Isn't that the same as that? So a bunch of different ways of doing this, and a little calculus. All right, try the homework tonight, and see how much you can remember without having to look it up, but write little notes to yourself to make sure you remember how to do it next time.